U.S. Marine Corps just dropped $10 million on a completely unarmed Phantom vehicle that flies a mere 30 feet above the ocean at a staggering 180 miles per hour. It carries zero heavy armor, yet it is built to survive the deadliest hypersonic missile zones on Earth. How exactly does this multi-ton machine cheat the laws of physics to become entirely invisible to enemy radar? Let's break down the radical engineering behind the Regent Viceroy Seaglider.
Right now, at this exact moment, a Mach 3 supersonic anti-ship missile needs less than 180 seconds to acquire, lock onto, and obliterate a multi-billion-dollar amphibious assault ship. Massive 100,000-ton supercarriers are no longer invincible. They are floating bullseyes in the highly contested waters of the Pacific. The era of slow, lumbering naval logistics is officially dead. To survive, the United States Marine Corps is weaponizing the ultimate regulatory gray area, a phantom that skims the waves.
Let's break down the radical machine the United States Marine Corps is actively using to rewrite the rules of naval warfare, the Regent Viceroy Seaglider. The military logistical paradox is absolutely brutal. Moving heavy cargo across thousands of miles of open water in a traditional displacement hull limits you to a painfully slow 15 knots, making you an easy target for enemy submarines and long-range precision strike capabilities. The Viceroy entirely shatters this severe constraint, measuring exactly 55 feet in length with a wingspan of 65 feet. This 100% electric platform is a $10 million tactical gamble, funded directly by the Marine Corps Warfighting Laboratory. It operates completely independent of vulnerable forward supply bases or massive runway infrastructure. It flies a mere 30 feet above the ocean's surface at a staggering cruising speed of 180 miles per hour, as it completely cooks the traditional military logistics timeline. That precise altitude is intentionally low enough to exploit the Earth's curvature and completely vanish beneath the radar horizon of advanced enemy destroyers.
Yet fast enough to easily outrun absolutely any interceptor vessel on the water today. Lacking heavy armor, its survivability relies on extreme speed. By fusing the heavy payload capacity of a surface boat with the high-end velocity of a fixed-wing aircraft, the Viceroy flawlessly bypasses the lethal A2/AD sensor networks, paralyzing traditional amphibious strike groups. Imagine a high-stakes covert insertion executed under the cover of absolute darkness. The Viceroy glides ruthlessly through the night, powered by a distributed electric propulsion system utilizing 12 independent motors mounted on its wings, running entirely on advanced battery architecture. It generates zero carbon emissions. More importantly, it leaves virtually zero thermal exhaust signature for sophisticated heat-seeking surface-to-air munitions to lock onto. It operates an astonishing 30 decibels quieter than a conventional combustion engine aircraft or rotary wing platforms like the V-22 Osprey. This extreme acoustic and thermal cloaking allows it to slip right past advanced electro-optical and infrared surveillance networks completely undetected. It is essentially a mechanical ghost, a phantom logistics node capable of rapidly transporting 3,500 pounds of mission-critical cargo, lethal autonomous drone swarms, or a fully equipped,
heavily armed MARSOC operations team straight through a heavily contested maritime kill zone without triggering a single early warning system along the way, completely outperforming legacy transport methods. Do you really think modern pulse Doppler radar systems can consistently track a low-profile target moving at nearly 300 kilometers per hour when it is entirely masked by extreme, turbulent oceanic wave clutter?
The sheer engineering brilliance required to conceptualize and deploy this revolutionary aerospace technology is what maintains absolute American air and naval superiority in hostile environments. If you are utterly fascinated by the sheer power of military innovation and incredibly proud of the relentless technological advancements driving the United States forward, hit that like button and subscribe right now. Your vital support directly fuels our intense, uncompromising deep dives into these phenomenal defense platforms. But how exactly does a heavily loaded, multi-ton block of aerospace-grade aluminum actively fly mere feet above the highly aggressive surface of the ocean without being instantly crushed by the massive drag of the water below?
The answer lies in mastering a highly complex, fiercely unforgiving aerodynamic phenomenon known as the wing-in-ground effect, or WIG, when a fixed-wing aircraft flies at an exceptionally low altitude, specifically within a distance equal to 1/2 to a full wingspan above a flat surface. The fundamental laws of physics dramatically shift in your favor. As the Viceroy's 65-foot wingspan cuts through the atmosphere at 180 miles per hour, it violently compresses the air trapped between the underside of its wings and the ocean's surface. This violent compression instantly generates a dense, high-pressure dynamic cushion of air. This invisible cushion actively pushes up against the airframe, massively boosting lift. Simultaneously, the proximity to the water physically interrupts the formation of wingtip vortices, those massive, energy-draining spirals of turbulent air that normally induce heavy aerodynamic drag on conventional aircraft flying at 30,000 feet. By flattening these vortices, the Seaglider experiences a radical surge in aerodynamic efficiency. You are literally riding a hyper-compressed bubble of air, maximizing payload capacity while drastically slashing energy consumption.
This underlying scientific concept is not new. During the height of the Cold War, the Soviet Union desperately tried to weaponize this exact physics glitch. They built colossal WIG vehicles categorized as ekranoplans. The most infamous was the Korabl Maquette, designated the CIA analysts panicked when spotting this 544-ton behemoth on satellite imagery, dubbing it the Caspian Sea Monster. It was 301 feet long and designed to carry lethal P-270 Moskit anti-ship cruise missiles at 310 miles per hour. But the Soviet engineering doctrine fundamentally relied on sheer, unadulterated brute force to tear a 544-ton steel Leviathan away from the aggressive suction of the water. The KM required 10 massive Dobrynin Vi D7 turbojet engines just to overcome the initial hydrodynamic drag. Water is roughly 784 times denser than air. Pushing a massive hull through that extreme density at takeoff speeds requires astronomical amounts of thrust, obliterating fuel efficiency and tearing the airframe apart under immense structural fatigue. The Soviet programs ultimately collapsed under their own catastrophic weight and horrific maintenance nightmares. America just completely reinvented the playbook. Instead of fighting the ocean's crushing density with massive fuel-guzzling jet turbines, the Regent engineers integrated an utterly brilliant 3-stage mechanical sequence. The absolute game-changing breakthrough of the Viceroy Seaglider isn't just its wings, it is its highly advanced, fully retractable hydrofoil system. This is the exact technological pivot where American ingenuity completely outmaneuvers legacy Soviet failures. When initiating deployment from a secure coastal facility or a forward-deployed amphibious transport dock, the Viceroy begins in Mode 1. It operates exactly like a traditional maritime vessel, floating steadily on its specialized deep V hull, maneuvering through congested maritime traffic at a controlled speed of roughly 12 knots. The hull expertly slices through standard surface chop, providing crucial stability. But as the mission timer ticks down, the 12 independent electric motors engage, generating massive torque. As the velocity rapidly increases, the secondary phase initiates. At approximately 45 knots, sleek, underwater composite wings, the hydrofoils, deploy downward. This is Mode 2. The kinetic energy generated over these submerged foils generates immense hydrodynamic lift, physically ripping the entire multi-ton aerospace-grade aluminum chassis completely out of the water. The Viceroy is now a foil-borne platform, skimming precisely 5 feet above the cresting waves. Hull drag drops to near zero. The ride instantly smooths out, completely neutralizing the violent, bone-rattling kinetic pounding of the oceanic wave action that historically destroyed Soviet ekranoplans. The electric propulsion system now pours 100% of its raw thrust into pure horizontal acceleration. Hitting the critical velocity of 70 knots. Mode 3 engages. The hydrofoils seamlessly retract flush into the hull to eliminate all remaining hydrodynamic drag. The tactical vehicle breaks completely free from the water's grip,
locking into its WIG altitude of 30 feet and accelerating to its maximum cruise velocity of 180 miles per hour. It is an absolute masterpiece of modern mechanical engineering. But let's pause and analyze the severe logistical reality. You are intentionally fusing advanced aerospace electronics with highly corrosive maritime submarine technology into a single, tightly packed mechanical platform. Do you honestly believe integrating delicate aviation-grade sensors with heavy-duty aquatic hydrofoils is a sustainable strategy? Or is it a catastrophic maintenance nightmare waiting to happen in salt-corrupted environments? The engineering complexities are undeniably terrifying. Yet the tactical payoff is unparalleled. Owning a perfectly engineered, pristine aerodynamic system is one thing. But into exactly what brutal, high-stakes campaigns does the Pentagon actually intend to throw this machine on the global tactical map?
The ultimate theater of application for this unprecedented technology is the sprawling, highly contested maritime expanse of the Indo-Pacific, operating under the aggressive tactical framework of Expeditionary Advanced Space Operations, or EABO. The United States Marine Corps acknowledged that concentrating troops on massive 45,000-ton amphibious assault ships simply provides the adversary with lucrative, unmissable targets for hypersonic saturation strikes. EABO completely inverts this legacy model. The Pentagon is actively scattering highly lethal, hypermobile platoons across dozens of isolated coral atolls spanning the First Island chain. This radical decentralization guarantees survival, but it instantly creates an absolute logistical nightmare. How do you consistently sustain, supply, and extract a heavily armed Marine Littoral Regiment isolated hundreds of miles behind enemy lines when your traditional supply vessels are actively being hunted?
This is precisely where the Viceroy transitions from a fascinating engineering experiment into the singular, irreplaceable linchpin of modern contested logistics. Traditional surface connectors, like the Landing Craft Utility LCU, plod along at a miserable 11 knots, requiring accessible deep water ports and massive fuel reserves. They are sitting ducks. The Seaglider entirely bypasses these fatal vulnerabilities, executing a clandestine resupply run. It can autonomously deliver precisely 3,500 pounds of Class 5 ammunition, such as highly sensitive components for naval strike missiles directly to a hostile, completely unprepared shoreline. Requiring absolutely zero port infrastructure fundamentally changes the resupply cadence. Furthermore, by stripping away the heavy burden of aviation fuel logistics, a dispersed forward unit simply plugs the vehicle directly into a tactical 100 kilowatt mobile microgrid or a silent portable generator, rapidly charging its battery banks while remaining completely invisible to enemy thermal targeting networks. The second core tactical application shifts the focus from lethal cargo to human survival, high-speed medical evacuation. In a peer-to-peer maritime conflict, securing the golden hour, that unforgiving 60-minute physiological window for life-saving trauma surgery is nearly impossible utilizing legacy rotary wing assets. A conventional UH-1Y Venom helicopter maxes out at approximately 160 knots and broadcasts a massive acoustic and radar signature, drawing enemy surface-to-air fire like a magnet. The Viceroy fundamentally re-engineers the medevac equation, serving as a hyper-fast flying ambulance. Its modular, pressurized cabin boasts an internal volume of exactly 746 cubic feet. This expansive architecture allows combat medics to immediately configure the space with 3 standard NATO medical litters, alongside heavy-duty mobile resuscitation technology, crucially transitioning from the violent,
bone-rattling mechanical vibration of standard helicopter flight to the aerodynamically stabilized, hyper-smooth WIG flight path drastically reduces critical physical stress on heavily traumatized casualties during extreme combat extractions.
The most lethal application resides in his third mandate, Special Operations Infiltration and Exfiltration. Darkness is the ultimate ally for Tier 1 operators. Imagine a Marine Forces Special Operations Command MARSOC strike element executing a covert nighttime insertion. Dropping them from a high-altitude C-17 Globemaster instantly triggers early warning radar nets. Inserting them via a $3 billion Virginia-class nuclear attack submarine is tactically sluggish and risks exposing a strategic asset in shallow littoral waters. The Seaglider provides the ultimate operational middle ground. Operating entirely under the cover of night, It exploits its profound acoustic advantage to approach a hostile beachhead in near absolute silence. Without the deafening rotor wash of an Osprey or the massive thermal exhaust bloom of a jet turbine, the Viceroy can touch down directly on deserted oceanic swells,
dispatching or extracting the Special Forces unit before coastal defense sensors can even register a kinetic anomaly. What truly underwrites the success of these high-stakes missions is the machine's extreme mechanical redundancy, driven by its sophisticated distributed blown wing architecture. The 12 independent electric motors mounted along the wingspan are not merely thrust generators. They constitute a highly advanced, fail-safe survivability matrix. In a conventional aircraft, a single 12.7mm heavy machine gun round to the central engine block ensures immediate catastrophic failure. The Seaglider is structurally immune to this single point of failure. If hostile anti-aircraft shrapnel obliterates 2 or 3 of its electric propulsion units during a hot extraction, the onboard fly-by-wire flight control computers instantly reallocate power to the surviving motors. This asymmetric thrust is automatically compensated in milliseconds, allowing the heavily damaged craft to maintain vital lift and confidently limp back to friendly waters. When analyzing a night operation, which do you believe is the more terrifying weapon, the absolute ghostly silence of an electric powertrain, or the sheer inescapable speed of 180 miles per hour in the pitch dark? But there is one harsh, unforgiving physical limitation that even America's greatest aerospace engineers have not yet been able to overcome. What is that fatal weakness? That fatal weakness is the harsh, unyielding limitation of modern electrochemical energy density. The current generation of lithium-ion battery architecture strictly caps the Viceroy's maximum operational range at exactly 180 nautical miles in the heavily contested 63 million square mile expanse of the Pacific Ocean, where the distance between strategic outposts like Guam and the first island chain spans thousands of miles. A 180 nautical mile radius is practically a local commute. To truly execute deep strike logistics and sustain a prolonged theater campaign, Regent engineers must aggressively pivot to a hybrid electric variant by integrating advanced, lightweight turbine generators to charge the battery banks mid-flight. The Pentagon expects to push that critical operational range past the 1,000 nautical mile threshold, completely unlocking the platform's strategic long-haul potential. Then, you must calculate the unforgiving wrath of Mother Nature. The Viceroy's advanced deep V hull and highly specialized retractable hydrofoil system are officially engineered to handle Sea State 5 conditions. This means the flight computers can safely execute autonomous takeoffs and landings amidst chaotic 13-foot cresting ocean waves. However, the Pacific Theater is the undisputed domain of Category 5 super typhoons. Throw this lightweight 55-foot composite airframe into a Sea State 7 or 8 environment, facing monstrous 20 to 30-foot kinetic swells, and the hydrodynamic shear forces will violently rip the wings apart. Furthermore, stripping away heavy armor to maximize payload and speed means the Viceroy operates with absolutely zero defensive countermeasures. It carries no radar-jamming electronic warfare pods, no defensive chaff, and no kinetic interceptors. If a visual patrol spots it, it is entirely naked to enemy fire. But the Department of Defense's vision for ground effect technology does not stop at a 3,500-pound payload. Enter the Defense Advanced Research Projects Agency, DARPA. They are currently funneling hundreds of millions of dollars into a much darker, radically larger WIG sibling, the Liberty Lifter. Boeing's Aurora Flight Sciences is actively designing a ground effect Leviathan with the sheer, massive cargo capacity of a C-17 Globemaster. We are talking about a strategic transport platform engineered to haul up to 270,000 pounds, take off in Sea State 4, and sustain flight for up to 10,000 nautical miles. Imagine a fleet of these giants carrying fully loaded mechanized armor, skimming 100 feet above the Pacific, and deploying an entire Marine Expeditionary Unit directly onto a hostile beachhead without ever touching a paved runway. This aerospace revolution isn't strictly confined to classified military black projects. The commercial sector is aggressively hunting this exact technology. Regent has already secured a staggering $10 billion in confirmed commercial orders from investors like Peter Thiel's Founders Fund, heavyweight aviation and maritime giants like Japan Airlines, Mesa Airlines, and Brittany Ferries are actively writing massive checks. Why? Because the Viceroy completely bypasses the multi-billion-dollar logistical nightmare of modern airport infrastructure. It transforms existing low-tech coastal ferry terminals into high-speed, zero-emission aerospace hubs, cutting regional travel times by up to 70% without the need to pour a single yard of concrete for a runway. But here is the ultimate mind-bending twist. The single greatest bottleneck threatening to kill this revolutionary leap in transportation isn't a flaw in the electric propulsion, and it isn't an enemy hypersonic missile. It is bureaucratic red tape. The Viceroy currently exists in a paralyzing regulatory gray area. Naval Air Systems Command and the Federal Aviation Administration look at the 65-foot wingspan and demand it be certified under highly rigid, extremely expensive aircraft regulations. Meanwhile, Naval Sea Systems Command and the Coast Guard look at the hull, noting it never flies higher than 30 feet and firmly classify it as a maritime vessel. The United States government literally does not know if this machine is a boat or an airplane. The most advanced aerospace leap of the 21st century is currently suffocating under a stack of outdated maritime law. If you were rewriting the regulatory code right now, would you officially classify the Seaglider as a low-flying aircraft or a high-speed maritime boat? Let me know your exact verdict in the comments below. The era of massive supercarriers might be closing. The future of naval warfare won't be decided by who has the biggest guns, but by who can move like invisible ghosts across the waves. If you want to stay ahead of the black budget technologies actively rewriting the rules of global combat, hit that like button and subscribe right now.